In this video, we are going to discuss auxiliary equations with real irrational roots. This video is in continuation with part 1 and part 2 of my earlier videos on linear differential equations with constant coefficients. I suggest you to watch those videos to understand this video properly. I have provided the links of those videos in the description box. Hello friends, you are watching YouTube channel Number Collage. This channel features videos on mathematical concepts. Effort has been made to explore the concepts through basic mathematical ideas. Hope you will like my effort. We know that real irrational roots such as alpha plus root beta and alpha minus root beta appear in pairs where alpha is rational and root beta irrational. Solution of auxiliary equation is y equals c1 e raised to alpha plus root beta into x plus c2 e raised to alpha minus root beta into x, which is c1 e raised to alpha x e raised to root beta x plus c2 e raised to alpha x e raised to minus root beta x. Taking e raised to alpha x a common factor, y is e raised to alpha x into c1 e raised to root beta x plus c2 e raised to minus root beta x. Now we have e raised to root beta x plus e raised to minus root beta x upon 2 is cos h root beta x, and e raised to root beta x minus e raised to minus root beta x upon 2 is sin h root beta x. Adding them together, e raised to minus root beta x minus e raised to minus root beta x will be 0, and we will get e raised to root beta x equals cos h root beta x plus sin h root beta x. Subtracting them, e raised to root beta x minus e raised to root beta x will be 0, and we will get e raised to minus root beta x equals cos h root beta x minus sin h root beta x. We will use these values of e raised to root beta x and e raised to minus root beta x for this e raised to root beta x and e raised to minus root beta x in equation 1. So this equation 1 becomes y equals e raised to alpha x into c1 cos h root beta x plus sin h root beta x plus c2 into cos h root beta x minus sin h root beta x. By rearranging the terms, we get y equals e raised to alpha x into c1 plus c2 cos h root beta x plus c1 minus c2 sin h root beta x. Y equals e raised to alpha x into putting a for this c1 plus c2 cos h root beta x plus putting b for this c1 minus c2 sin h root beta x. In the regular form, we write y equals e raised to alpha x. Now we will substitute arbitrary constant c1 for this a cos h root beta x plus we will substitute arbitrary constant c2 for this b sin h root beta x. What if the real irrational roots are repeated twice? That is alpha plus root beta whole square and alpha minus root beta whole square are the roots of the auxiliary equation. In that case, the solution will be y equals e raised to alpha x into c1 plus c2x cos h root beta x plus c3 plus c4x sin h root beta x. So we note here that when the auxiliary equations have real irrational roots, solution consists of hyperbolic functions cos h root bx and sin h root bx. Let's solve an example. D square minus 2d minus 4 into y equals 0. Auxiliary equation is d square minus 2d minus 4 equals 0. This is a quadratic equation in D. Solving it by quadratic formula, D is minus b, that is minus of minus 2 plus minus square root of b square minus 4ac. B square is 4 minus 4ac will be plus 4 fours are 16 upon 2a, that is 2. This is 2 plus minus square root of 20 will be 2 square root of 5 upon 2. 2 into 1 plus minus square root 5 upon 2. Cancelling this 2. D is 1 plus minus root 5. This is a real irrational root and its solution will be y equals e raised to 1x, that is e raised to x into c1 cos h root 5x plus c2 sin h root 5x. So this is the solution involving hyperbolic functions when the roots are real irrational. Solve 5 d2y by dx square minus 6 dy by dx minus 2y equals 0. In terms of d, this will be 5d square minus 6d minus 2y equals 0. Auxiliary equation 5d square minus 6d minus 2 equals 0. This is a quadratic equation in D. By formula method, its solution will be D equals minus b, that is minus of minus 6 plus minus b square minus 4ac. B square is 36 minus 4, a is 5, c is minus 2 upon 2a. 2 into 5 10, which is 6 plus minus square root 36 plus 40 upon 10, which is 6 plus minus 76. We write 4 into 19 upon 10. 6 plus minus 2 square root 19 upon 10. D is 2 into 3 plus minus square root 19 upon 10. So finally D is 3 upon 5 plus minus square root 19 upon 5. So the roots here are real irrational type. Solution of equation will be y equals e raised to 3 upon 5x into c1 cos h root 19 upon 5x plus c2 sin h root 19 upon 5x. Solve 2 d2y upon dx square plus dy upon dx minus 4y equals 0. In terms of d, this will be 2d square plus d minus 4y equals 0. Auxiliary equation 2d square plus d minus 4 equals 0. This is a quadratic equation in D. We will solve it by formula method. So by quadratic formula, D is minus b, that is minus 1 plus minus square root p square, that is 1 square 1 minus 4ac, 4 into 2 into minus 4 upon 2a, 2 2s are 4. It is minus 1 plus minus square root 33 upon 4. So D is minus 1 upon 4 plus minus root 33 upon 4. These roots are of the type real irrational. So the solution will be y equals e raised to minus x upon 4 into c1 cos h root 33 upon 4 x plus c2 sin h root 33 upon 4 x. If you like this video, please like it, share it, and subscribe to this channel. See you in the next video. Until then, keep watching Number Collage. Thank you.